Compare nuclear and coal and natural gas, which are really the three big fuels for baseloading electricity generation. How do you see the landscape with those three?
Coal, natural gas, and nuclear each have their pluses and minuses. In terms of CO2 emissions, coal-fired power plants are by far the worst contributor to global warming of those three. A natural gas-fired power plant produces about half as much CO2 as a coal-fired plant, and nuclear plants don't emit CO2. So that's the CO2 side of the equation. Methane is also a very potent greenhouse gas. Coal operations reduce very, very little methane, maybe a tiny amount. Nuclear releases no methane. The natural gas industry inadvertently releases a lot of methane in its operations, and that has to be counted as one of the negatives of natural gas. In terms of land use impacts, coal has mining techniques that are incredibly destructive, up to and including the removal of entire tops of mountains. Natural gas has environmental impacts that are distributed much more widely instead of being concentrated in one place. There's a lot of surface impact just from roads and just from drill pads, not even counting the risks of water pollution or other forms of pollution. Nuclear, when I think of nuclear, I think of using huge amounts of water for cooling. Coal plants and gas-fired power plants also use water, but nuclear plants are even more water intensive. And then, of course, waste disposal. Yes, coal has its waste that need to be taken care of, and natural gas generates waste that need to be taken care of, but neither of them generate radioactive waste that needs to be taken care of for thousands of years.
Right. I mean, you mentioned water gets used heavily and extensively in the industrial energy generation processes.
Water is becoming a very, very big issue. Yeah, it has always been a big issue, but as water supplies become more scarce and the demand for water increases, we have what looks like an unsustainable situation on our hands. So we are more and more focusing on what we call the energy-water nexus, which is to say examining how much energy it takes to do what we want to do with water, and also examining how much water it takes to do what we want to do with energy.